This spreadsheet, we're going to look at the calculations involved with binomial option pricing using the Cox-Ross-Rubenstein model, also known as the log-normal model. This model differs from the risk-neutral evaluation of binomials with the calculation of the volatility of the underlying asset. So, let's take a look at some of the calculations. Here we have the stock strike, risk-free rate, volatility, years to maturity, and the number of steps. So this is going to price it in a 6-month period because we have 2 steps for 1 year. Here is the time per step. And here's the formula. Okay, this formula is to get our up now, we're going to include the volatility of the underlying asset and the square root of time. So that's the formula for up. Down is the inverse of up. P is this formula, e to the RT minus D divided by U minus D. That's our up probability. This is our discount factor, which is E to the negative RT. Here are our steps. So we have 0, 1, and 2 steps, and the time period, each of these being a half a year. So we can see 0.5. Here's our stock. I know this is protected. We start out with $30. We have up and down. So we're going to have the stock price multiplied by up and the stock price multiplied by down. This next step would be this multiplied by up and this multiplied by down. And this would be multiplied by down, and that will give us our stock price in this tree. Our call price utilizes this formula, which is the standard formula for the call. This end over here, exp to the minus r times t, is the discount factor. Over here, discount rate. So we start out here with the stock minus the strike price, which is basically the intrinsic value of this option. We can never go below 0, so we have the max of 0. And these are our call prices for this group of data. And we use all of these. Okay, here's our put price. Our put price using the put call parity formula is here. Over here is strike. This is our over here E times RT, e to the negative RT, which is the same as the discount factor. So this is basically we take the strike minus stock, which is opposite of the call, which is the call is the stock minus strike, so these two are opposite. We take the max of this formula, a probability, so we're doing the probabilities for these two, and then our final calculation is the put value. We basically have the same calculator with 4-step. So this one we could do this in quarters. So if you can see, basically everything is exactly the same except years to maturity 1, and now we have 4 steps. So here we go, we have 4 steps. Same thing. Same formulas. And from these are basically all up. And from here we just price it down. We keep pricing it down from that one, down from this one, and this one be down from that one, and that's how we get our stock prices. Same with our call price. Stock minus strike is our call price here, which is basically the intrinsic value, how we start at the end. And then we do the up probability. We use our formula here. Same as we did the 2 model. It works its way down. Same thing. And here is our put. Put's the opposite. Put is the strike minus the stock. And we keep working our way down, and we finally get our formula here.